So we just did a resting potential. So now we're going to just talk about graded and action potentials. Just to set up that resting potential again, to get to a resting potential, we need a positive terminal outside of the cell. We need a negative terminal inside the cell. Our positive terminal outside the cell, we have sodium. And with sodium, there is a chemical gradient because it's in high concentration outside of the cell, pulling it towards the inside of the cell. And then we also have, because of the positive and negative charge, we have an electrical gradient pulling it towards the inside of the cell. In opposition, we have potassium inside the cell. And potassium has opposing concentration gradient, or opposing, not concentration gradients, opposing electrochemical gradients. So it has a chemical gradient. Sorry, grab the electrical one first. So electrical gradient from the positive to the negative charge inside the cell, and then a chemical gradient towards the outside of the cell. Sodium ends up being the positive terminal. The negative terminal is the anion protein inside the cell, and that's our setup. So if we were to measure the electrical potential inside the cell at this period of time, so here is 0 millivolts. We said the inside of the cell is slightly negative, so maybe minus 70 millivolts, minus because it's negative, so we're sitting down here. The difference between a graded potential and an action potential is that graded potentials are only going to move us a little bit, whereas action potentials are all or none. The difference in these two is that a graded potential is going to be caused by some either chemically or mechanically gated cell. And then on the other end here, action potentials are going to be linked to voltage gated channels. All right, so what's going to happen is, picture if we open sodium or potassium channels, sodium wants to rush into the cell. What direction does potassium want to move? Doesn't matter. If we open a channel, we open this door wide open, why won't potassium go anywhere? Because as much as it wants to go out, because of its chemical gradient, it wants to go in because of having that electrical gradient pulling it towards the inside of the cell. So if we add some sort of gated channel, make this a sodium channel. Now that's impossible to see, so let me just double that over here with a little pencil. So sodium, and we'll just make this a chemically gated channel. If that were to open, then sodium would start to move into the cell. And so what we would see as sodium moves into the cell is we start moving towards 0, or we depolarize the cell.